All right, this is the Unit 3 test review for pre-cal. Remember that this review is going to be a daily grade and it's worth plus 5 bonus points. Okay, so the first thing they want you to do here is that they want you to sketch the angle in standard position and then determine which quadrant in which the angle lies. So there's a couple different ways to do this. You could just use the unit circle to find out where 5 pi over 4 is. Or if you wanted to, you could convert it to degrees. Okay, and if you convert it to degrees, you get 225 degrees. So you would start here. So this is 90. This is 180. And then if I go 45 more degrees, then it would be in quadrant 3. Now, also, if you just look on here, which, I mean, this is kind of the easier way. This is 5 pi over 4 right here, and that's in the third quadrant. Okay, on the next one, they want to determine the reference angle. So with reference angles, you'll need to remember that they always have to be positive. So if I were to sketch negative 225, again, if it's negative, I start here. So 90, 180, and then I go another 45, so I'm right here. Okay, so remember, the reference angle is all about how far away from the x-axis it is. So there's my x-axis. So this was 45 degrees away, so my reference angle is 45 degrees, because it's all about how far away from the x-axis. All right, on number 7 here, again, because you have the unit circle, what you could do is you can look over here. So they wanted 7 pi over 6. So here's 7 pi over 6. And if you notice, that's where the angle's at. And so how far away from that x-axis is it? Well, that's 210 and that's 180. So the difference is 30. So your reference angle here would be 30 degrees. Okay, on these here, you're just converting the angle into radian measure. So I'm going to take this degree, and then I'm going to multiply it by pi over 180. And if I do that, I'm just going to keep simplifying it. So I can tell both of these can be divided by 3. So this would be 60, and this would be 61. So then my final answer here would just be 61 pi over 60. Okay, on the next one down here, they want you to convert the radians into degrees. So if I do that, this should actually, hold on, I didn't think that was right. That's probably why you heard all the shuffling. This should be 62, which reduces this to 31 over 30. Okay, so down here, this is where they want you to convert the radians into degrees. So I'm going to now do 180 over pi. And then what I can notice is that I can cancel out the pi's. I can also divide this by 5, which means I can divide that by 5. And then that leaves me with that. So if I multiply 36 times 6, that gives me 216 pi. All right, the next one, it says find the central angle of a circle with a radius 7 and an arc length of 42. Now, I'm not going to do this one because this one is already in radians. And if you look at the key online, it'll already have all the work for you. But let me focus on this one. So this one says find the length of the crust, which is going to be the arc length. Okay, that's going to be my arc length. If the radius is 16, so that's my 16, and the central angle is 30 degrees using the formula arc length equals radius times theta. Now, this 30 degrees needs to be in radians. So what I need to do here is do 30 pi over 180 If I divide that by 30, I get 6. If I divide that by 30, I get 1. So that leaves me with pi over 6. So now I can use that pi over 6 to find out what my arc length is, or the size of the crust. So S equals 16 times pi over 6. And then if I do that, that gives me 16 pi over 6, which equals 8 pi over 3. So you could leave your answer like that, or if you decide to divide it out, it becomes approximately 8.38 inches. Okay, on this one here, they want you to find a couple different things. Now, because they want me to find the positive coterminal here, I need to make sure I add 360. And then remember, if they want the negative coterminal, that's when you subtract 360. So this one I'm going to focus on is going to be 120. So if I draw a picture of 120, this is 90. And then if I do another 30 there, that's my 120. So that means the distance from here to here is going to be 60. Now, if I add the 360 to this for my other one, that's going to be 480, because 120 plus 360 is 480. I'm going to write it over here. I'm running out of time, space. And then it says the terminal side lies in which quadrant? Well, the terminal side is where it ends. So I started here, so this is my terminal side, and it ended in quadrant 2. Okay, let's move on. So this one here, they're giving me a point that lies on the terminal side of theta, and then they want me to find cosine. So remember, cosine is A over H. All right, so I'm going to draw a coordinate plane. I'm going to put a point at -3, and then up 6, okay? And then I'm going to draw my triangle. Okay, so that's my triangle. So I went over -3, up 6. All right, now, that's where my reference angle is. So this is my opposite, this is my adjacent, but I need to find out what my H is. So here, what I'm going to do is, I'm going to do the Pythagorean theorem. So I have 6 squared plus -3 squared equals c squared. That gives me 36 plus 9 equals c squared. That gives me 45 equals c squared. And if I do the square root of it, I find that c equals the square root of 45, or 3 times the square root of 5. Okay, so I know that the hypotenuse here is 3 times the square root of 5. Now, in order to do this, I need to have the a and the h. Well, my a is -3, so cosine theta equals -3, because that's my adjacent, over my hypotenuse, which is 3 times the square root of 5. Okay, well, oops, I can't see that. So now you'll notice I have the radical in the bottom, so let me rationalize it. So times square root of 5 times square root of 5. So what I then have left is, I have -3 times the square root of 5. If I multiply these two, I get 5. And then if I multiply it times the 3, I then get 15, so over 15. And then remember, I can actually simplify that a little bit further. Oh, I just noticed, y'all. I accidentally skipped over to 37. I'm going to keep going, though. Okay, so here, for 37, I can actually simplify this a little bit more, because both of these can be divided by 3. So because both of those can be divided by 3, I end up with -1, which I don't need to put the 1, over 5. And that's my final answer. Okay, now over here, they're giving me another point. Actually, this will be the same thing. What I will say about this one is that now this will be -5, and I go down -3. And again, you can just do that triangle there, and then you've got to find out what the hypotenuse is. Okay, and again, the answers are on the key. All right, on 39 here, it says x is an angle in standard position with 0 is less than or equal to x, which is less than or equal to 2 pi. So pretty much, y'all, that's the whole unit circle. So determine the quadrant angle x will lie, determine where the quadrant angle x will lie in for each given situation. Alright, so for here, I know that sine is my x, so, sine is my y, so I know that y has to be less than 0. So if y has to be less than 0, that means it can't be these two quadrants, because this is where y is positive. Okay, then it says tan is greater than 0. So I know that tan is y over x, and I know it has to be greater than 0, which means that these can both be positive, or they can both be negative, because a negative divided by a negative is a positive. So what that then means is that it has to fall into quadrant 3. Okay, so on this one, now they're talking about cosine. So I know cosine is my x, so x has to be less than 0. So since it has to be less than 0, it can't be those two quadrants, because that's 1, 2, 3, 4, okay? Then it says cosecant has to be greater than 0. Well, cosecant is related to sine. And remember, sine is your y, so it's really 1 over y has to be greater than 0. Well, your 1 here has to be positive. Okay, which means that my y also has to be positive. Okay, so if that's the case then it has to lay in quadrant 2. Because down here is where all my y's will be negative, and this has to be greater than 0. Alright, on 41, they want you to find secant if tan theta is 7 over 6, and they tell me that sine is less than 0. So again, sine is where is your y. So if I draw a picture here, I know that y has to be less than 0, so it can't be any of those. Okay, but then I also know that tan is my opposite over my adjacent. Okay, so again, I've got two choices. This is positive. Well, you can get a positive by dividing a positive and a positive, but you can also get a positive by dividing a negative by a negative. So that means it has to be in this quadrant, because points down here are positive and negative. Okay, so it can't be over here. Okay, so if I draw this, the x is always your adjacent, so that has to be negative 6. And then if I go down, that's my opposite, so negative 7, and then I draw my hypotenuse. Okay, so now I need to find out what the hypotenuse is. So negative 6 squared plus negative 7 squared equals c squared. 36 plus 49 equals c squared. So c squared equals 85, and then square root, c equals square root of 85. And I don't believe that can be factored any further. Let me just double check. Yeah, I think that's pretty much it. Okay, so now what I'm going to do is I'm going to find out what secant is. All right, well, secant is related to cosine. So remember that secant theta is related to cosine. So because it's related to cosine, cosine is A over H, okay, which means that secant will be H over A. Okay, well, I know that my hypotenuse is the square root of 85, and then my adjacent side is right here, so negative 6. And again, be really careful of your signs here. I just noticed even in my key I made a mistake with that. So just be really careful with your signs there. If you're going to the left, it's negative. If you're going down, it's also negative. Okay, on this one here, really the shortest way to do this, and I'll show y'all, but here's your square, and they're telling you this diagonal is 12 times the square root of 2. So because it's a square, these are all the same side. And so really what happens is this ends up being 12 and this ends up being 12. Okay? And if I were to do the Pythagorean theorem, I would also get the same answer. So when they ask for the length of the side, it's going to be 12. Now mathematically, this is how it would look like. You would have a squared plus b squared equals c squared. Well, my c squared is the 12 times the square root of 2, at least that's my c. And then if you notice on a square, everything is the same. So I'm going to use s squared plus s squared equals 12 times square root of 2 squared. Well, if I combine like terms, that gives me 2s squared equals, and if I multiply this whole thing out, I'm going to get 288. And then if I divide by 2, that means s squared equals 144. And if I square root, s equals 12. But again, y'all, the easiest way is literally just always that number. So for instance, if the problem said the diagonal is 8 times the square root of 2, well, guess what? The length of the side is literally just 8. That's all it is. Okay? All right, on 44 it says one of the displays in a botanical garden is an herb garden planted in the shape of a square. Okay, so here's my square. The square measures 10 on each side. Visitors can view the herb from a diagonal pathway through the garden. How long is the diagonal pathway? So again, I'm trying to find what the hypotenuse is here. Okay, so I'm just going to do a squared plus b squared equals c squared. So 10 squared plus 10 squared equals c squared. So 100 plus 100 equals c squared. So 200 equals c squared. And then divide and divide. All right, so if I break that down, I know that 2 times 100 is 200. I know that this is my perfect square. So c equals 10 times the square root of 2. And again, look how this is related. Okay? Well, here, isn't this the side length? And look at that. There's the square root of 2. Just like up here. Isn't this the side length? And there it is, square root of 2. Okay? So with squares, because they are the same, that works out that way. Okay. All right, let's move on. I guess I'll try to get back in order. Let's go back over to 16 then, or 17. Okay, on 17, well, actually, let's talk about the bearings one. So with the bearings one, remember, 22.5 is the magic number. And then you want to always start at north, just like the North Star, just like sailors. So if I'm talking about east, southeast, well, this here is southeast, which means east, southeast would be here. East, south, east. So from here to here is 90 degrees. And then I add another 22.5. Now make sure you line up your decimals. And you get 112.5. And that looks awful the way I wrote that. So 112.5 degrees. So on the compass rose, every little mark you see is 22.5. Okay, on this one here it says a wheel rotates at 36 revolutions per minute. Okay, so 36 revs per 1 minute. And it says what is the angular speed in radians per minute? So remember, one full rotation or revolution is 2 pi. So 2 pi over 1 revolution. Okay, well, my revolutions will cross out. So now I'm left with 72 pi radians per 1 minute. Okay, on number 18, they want you just to kind of go through each of these and figure them out. So on the first one, they want you to look at angle A. So here's angle A. And then what's kind of strange about this is your opposite and adjacents are going to change depending on the reference angle. So for now, this will be my opposite, and then this will be my adjacent. So this will be this is my hypotenuse, blah, 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 blah. This is my hypotenuse, and then this will be my adjacent. Okay, so here, for the cosine ones, for the A, it's A over H, so 1 over 2. Okay, then let me do the other cosine one. Is there another one? Okay, so for cosine B, Oh, actually, let's do all the ones that have A's. Okay, so now for sine A, remember sine is O over H. Well, my O here is square root of 3 over the H, which is 2. Okay, so now it's going to change. Now I'm looking at B as my B in my reference angle. So if I'm looking at B as B in my reference angle, all this kind of changes. Oh no, I ran out of tape. Okay, so now this becomes my opposite. This is my adjacent, and this is still the hypotenuse. Okay, so for cosine, remember cosine is A over H. So this would be square root of 3 over 2. All right, and then for tan, so remember tan is O over A. So for this one, it would be 1 over the square root of 3. But again, you got to rationalize it. So square root of 3 times square root of 3. And that gives you the square root of 3 over 3. All right, on this one down here, it says, given just one trig function, draw the triangle and identify all other trig functions. Okay, so they're giving me cosine, so I know this is my A and this is my H. So if I draw my triangle, this is 29, it's across from that's my hypotenuse. Okay, and then this is my reference angle. So that means that this is going to be my opposite, and this is my adjacent. Okay, now I know that the adjacent is 20. So what I now need to do is I need to do Pythagorean theorem. So because I'm finding a leg, I'm just going to subtract these. So 29 squared minus 20 squared equals. All right, 29 times 29 is, I think it's 829, but let me just double check. 841. Okay, so this is 841 minus 400, and that's going to give me 441. And then if I do the square root of it, the square root of that will be 21. Okay, so now I'm going to do sine. So sine is O over H. So 21 over 29. Now I'm going to do cosine, which is A over H. Okay, so that's 20 over 29. Tan is O over A. So that's going to be 21 over 20. Cosecant is related to sine, so it's H over O. And that's going to be 29 over 21. Secant is going to be H over A. So 29 over 20. And then cotangent will be A over O, which will be 20 over 21. Okay, on this one down here, it says a ramp is designed to help people in wheelchairs move more easily from one level to another. If a ramp 16 feet long forms an angle of 12 degrees, what is the vertical rise of the ramp? Okay, so this is my O, this is my H, and this is my A. Now, they want me to find the O, the X, okay, which is on the opposite side, and they also are giving me the hypotenuse. Well, if I have O and H, that means I have to use sine. So sine 12 equals O over, I was going to write H. Should probably write 16 instead. Okay, so there it is. All right, so I'm just going to start solving it. So times 16, times 16, and then that gives me, make sure your calculator's in degrees. So 16 sine, 16 sine of 12, and that gives you 3.33. So X is approximately 3.33 feet. Okay. All right, let's move on. Let's take a look at 25. Now, 25, notice how they're giving you the side lengths. So anytime they want you to find that degree, you know you're going to use either the inverse of sine, the inverse of tan, or the inverse of cosine. You're going to use one of them, okay? So it says you got an airplane and 2,200 ground feet from its landing point. You want to determine the angle of descent. The plane descends in a straight line to the runway. Okay, so I know that this is the angle I'm going to find, so that's my opposite. This is my hypotenuse, and this is my A. Well, the numbers are on the O and the A. So I know I'm going to use tan. So theta equals the inverse of tan, and then 550 divided by 2,200. So again, make sure your calculator's in degrees. Let me see. Trying to get so there's not a glare. All right, there we go. Oh, okay. So now I'm going to do second tan, and then 550 divided by 2,200. And you get 14.04. So approximately, so theta equals approximately 14.04 degrees. Okay, on the next ones with evaluating, you do need the unit circle. So, for instance, remember, the main things you really need to remember here are that an ordered pair is made up of a cosine and sine. You also need to remember that tan is equal to cosine over sine. And then cotangent, let me just write it right here. So cotangent, excuse me, would then be related to sine over cosine. Okay, so let's start with sine. Let's start with this one. So I'm going to go look for 4 pi over 3. There it is. Of course, it's the one that's right off the thing. Okay, so there's 4 pi over 3. And then they give me sine, so that's going to be my y. And there it is. There's my y. So negative square root of 3 over 2. Okay, so let me go now look for cosine. Now cosine is my x. Let me go look for 2 pi. Here's 2 pi, and my x is 1. Okay, now the cotangent, again, gets a little harder. Let's start with tan. So I'm going to go look for 5 pi over 4. There's 5 pi over 4. Now what's nice about this is notice how I'm literally dividing the exact same thing. So anytime you divide the exact same thing, remember that's just going to equal 1. Alright, now cotangent, let me go look for pi over 6. There's pi over 6. So for cotangent, remember it's cosine over sine. So if it's cosine over sine, for pi over 6, I'm going to do the square root of 3 over 2 divided by, because again that's my cosine, divided by the sine, which is 1/2. And then remember, I'm dividing fractions. So I don't divide fractions, I multiply by the reciprocal. And if you notice, there's a shortcut here. I can cross out my 2's. So that just ends up being square root of 3. The most important part here, I would have to say, is to make sure that y'all are multiplying by the reciprocal. That's probably like the most important thing there, is to make sure you're doing that. Okay, blah, blah, blah. All right, so 34. Okay, so on 34, they wanted us to determine the exact values of the 6 trigonomic functions. So again, I could tell I have to use Pythagorean theorem again. So I'm going to do 11 squared minus 3 squared, and that'll give me c squared. So that gives me 121 minus 9 equals c squared, 112 equals c squared, and then square root, square root. Okay, and then what I notice is I can actually break this 112 down. I can get 56, what happened there? Okay, so that can be broken down to 56 and 2, which can be broken down to 8 and 7, and then 4 and 2, and then 2 and 2. Alright, so I notice I have one group of 2 here, Another group of 2 there, so that's going to be 4. Okay, so this is going to be 4. And then I notice I have this 7 left over here, so 4 times the square root of 7. Okay, so now I'm going to go through each of them. So sine, again, is O over H. Okay, well, let me make sure. So there's my O, there's my A, and here's my H. All right, so for O over H is going to be 4 times the square root of 7 over my H, which is 11. Okay, for cosine, remember that's A over H, so that's going to be 3 over 11. Now, it's easy when it doesn't have the radical. I'm just going to come over here and do 11 over 3. That's all you're going to have there. Okay. All right, and then for tan, that's going to be O over A. So for this one, it's going to be 4 times the square root of 7 over the A, which is 3. All right, and then here, and y'all, I just noticed on the key, I think I made a mistake on the key for this one, so you may want to check that. Okay, all right, so for the cosecant here, remember that's H over O. So my H here is 11. So 11 over 4 times the square root of 7. Now, because I have that radical on the bottom, I need to rationalize it. So times the square root of 7 times the square root of 7. So that gives me 11 times the square root of 7 over, now remember, square root of 7 times the square root of 7 is 7 times 4, which is 28. Oh, okay, so for cotangent, that's going to be A over O. So my A is 3 over 4 times the square root of 7. Again, let me do the square root of 7 times the square root of 7. So this gives me 3 times the square root of 7 over, again, the square root of 7 times the square root of 7 is 7 times 4, which is 28. Okay, if you'll take a look at 35, it says identify each of the following trig functions. So for this one, I'm just going to use the unit circle and go to 5 pi over 6. Okay, so there is 5 pi over 6. And they want me to do sine, so just remember sine is your y. So that's going to be 1/2. That's your y. Now cosine is your x. So if I again go back to 5 pi over 6, it's my x. So negative square root of negative 3 over 2. Or square negative and times the square root of 3 over 2. Okay, whew. And then remember my tan is just going to be the y over x, or sine over cosine. So I'm going to have 1/2 divided by negative square root of 3 over 2. Alright, and then if I just start kind of working out all the math, remember I don't divide by fractions, I multiply by the reciprocal. I notice I can cross those out. So that leaves me with negative 1 over the square root of 3. And again, I need to make sure that I rationalize that. So if I rationalize that, I need to multiply that by the square root of 3, and then multiply the top by the square root of 3. So my final answer is negative square root of 3 over 3. Okay, I hope that helped you. Let me know if you need any help. Go Astros. I'll probably be staying up late, so if you need help, just let me know. And that's about it.